Our next presentation is Developing Smart Building Technology Modules to Enhance Workforce Preparedness, a case for AI-driven academic and professional education. So, Professor Janice will be performing the presentation. She's a professor at the American Lawrence Technological University of Michigan, USA. Thank you, Professor Means.
Thank you. And I should say I'm doing this on behalf of my former colleagues, and I will be reading a little bit about their backgrounds to give them credit because they've really done the paper. And here we go. This actually presents, it's a very short lecture, so don't worry. It's Sustainability, Digital Environment. This is not it. This is it, sorry. It's been a long day. Developing smart building technology modules to enhance workforce preparedness. A case for AI-driven academic and professional education. This fits in very well with Dennis Knight's program for this year, in that providing modules, basically, and we'll talk about this in greater detail, for not only continuing education, but for education at university level. The authors of the paper, and Professor Walters is the first. She was the one that was going to be presenting this, but she could not come. She's a professor of practice in the architectural engineering program at the Department of Multidisciplinary Engineering at Texas A&M in College Station, and has collaborated in the areas of competencies for future-ready workforce, architectural engineering, pedagogy, and curriculum and instruction. Co-author with her, and I'm going to go right to the right now, is Dr. Shiato. She's a tenure-track assistant professor of marketing in the Dickey School of Business at Ohio Northern University in Atlanta, Ohio. She teaches classes in marketing, conducts research, and has presented and published in areas including professional skills development and teaching and learning with artificial intelligence. Both these ladies have been co-faculty with me at Lawrence Tech, and that's how I know them. Dr. Zhu, some of you may be familiar if you're at all in ASHRAE research, are familiar with Slipstream, which has done a lot of the work for research for ASHRAE. He's director in research innovation with 25 years of experience in building energy efficiency, focusing on controlled smart buildings and grid interactive systems. He's active in ASHRAE member, serving on several TCs, and he holds degrees from, I hope I can pronounce this right, Zhejiang University, I'm assuming that's Connecticut, and Iowa State University. And he's a PI and project PI and co-author, again, with the three authors. So I'm going to be, I apologize for reading a lot of this because it's not my presentation. In any case, we have a very long outline here. I'll let you scroll through it. All right, so as an introduction, smart building technologies do what? What do they do for us? They improve energy efficiency, resilience, they reduce carbon emissions, and provide grid load flexibility. But when we go to the curriculum that's available for this, there's a lack thereof, okay? Especially if it's integrating energy systems, smart building technologies, AI tools, IoT, devices in academia and for building professionals. So this education gap hinders the ability to attract talent to our industry, okay, for smart building design. And this whole project, it was set up, was a government-funded project through the United States, public-private partnership to develop this smart building curriculum for engineering students, but it's not only for that, it's for continuing education also. So the course should fulfill the need for AI-driven smart building technologies. And the paper outlines the project approach, the course materials, lessons learned, and suggests methods to scale smart building instruction. And that's where you're going to get all your answers, because I won't be able to answer any of your questions. So if you have questions, you can go to the papers or contact the authors directly. So what are the expected outcomes of the project? It actually resulted in a semester-long academic course. The course consists of 6 modules and 16 training videos. The 6 modules are primarily for engineering education, whereas the training videos, as I understand it, are for continuing education for building professionals. It includes benefits of energy systems, sensor technologies, IoT devices, smart building controls, which are listed here in specifically. She says federally agency, it's again the United States. A funded research project was an awarded grant, an aim for broad dissemination, and the good news for you is that anybody's going to be able to download these, which is great. It was a collaborative effort, and they strategized, they developed and validated the course content, provided innovative and iterative curriculum design. They indented to fill smart building competency gaps. I think that's meant to be intended. They designed for traditional engineering programs, and again, the dissemination is to the public. But it again also provides lifelong learning for building professionals. So the objectives are pretty close to what we just said, to build a module-based course material that was ready-made, packaged, scalable, with online training vehicles, and then to disseminate it. Build knowledge, continuing education, lifelong learning opportunities as well. Promote broader impact through partners and professional organizations. So the summary of the project outcomes, the team's charge was then to develop a semester-long course on new smart building course suitable for any engineering college curricula. The content was to be and did end up being packaged as adaptable and easy to follow modules. They produced 16 training videos, as well as I'd let you know that these again are free to universities, professionals, and to the general public. Topics are to cover smart building technologies, including AI. Content should provide industry trends and smart building benefits. And here's a list of the modules for the academic semester. It starts, of course, with an introduction, then it goes into fundamentals of building mechanical and electrical systems and building system integration. The second module is smart building technology drivers and trends. The third, fundamentals of smart building technologies. The fourth, advanced building energy management and controls. Fifth, applications of engineering tools and standards building operation. And the sixth, smart building technologies case studies, which should be very valuable for design and operation. The online sessions of 16 training videos, which is for the continuing education, are a little bit more elaborate than you can see here. Broadly, the first or the second through the sixth discuss or cover building systems. The 7th and 8th, sensors and IoT devices. The 9th through 13th, smart building controls. And 14th through 16th, smart building applications. So in conclusions and lessons learned for future work, first of all, they determined that The building technologies are not adequately covered currently in higher education, and I think that they are fulfilling a need in this. I believe they've developed best practices in developing and testing a curricula, not only providing the curricula, but developing it. The project's learning modules are systematically organized for scaffolding learning, and the lessons learned in course contact development. 1, involve project advisors early to review course outlines, including topics covered. Multiple rounds of internal and external technical expert reviews take time, so make sure you allow enough time if you're doing this. 3, collaborate with learning management system providers, and 4, structure course content and delivery with focus on learning effectiveness and assessment. And again, the training materials will be available for free by the end of this year. So very, very soon. These are some example slides of the PowerPoints that are used for the academic course. I'll give you kind of a bright, I know you probably can't read them from that distance. It gives you a flavor, for it. Here's an example of a couple of pages, if you will, from a video series, an assessment tool, because it does include assessments, which is very important when you're teaching, as those in the audience who are professors know. And that's pretty much it. She wanted me to read acknowledgments to thank you, Hellenic Tractor, for this opportunity to disseminate their work. Thanks to ASHRAE Society and all attendees for your interest. Thank you to our partners and funders of support, and it looks like she thanked me too for presenting on her behalf, and I hope I've done justice to it and it wasn't too boring watching me read through these. Thank you very much.
Thank you for the presentation. I'm sure we all have homework now. We need to see the... We have homework because we need to see the presentations and the videos. You said that will be open to the public.
Sorry, I forgot the resource page. There's a promotional video, and then there's a complete list of additional resources that are provided within the paper. I strongly suggest you go to the paper itself to see these. And I'm looking forward to seeing these modules myself. It should be very valuable. And I'll leave that up for a minute. Thank you so much.